So now that we have covered point slope form, we're going to explore a little bit more with using point slope form and writing more linear equations. To start this next section, I kind of want to review with you what parallel lines and perpendicular lines are. Parallel lines are lines that lie in the same plane and do not intersect. The symbol that they use right here, it's just like two straight lines right next to each other. That's the symbol for parallel. Another thing I want you to add about parallel lines is that they have the same slope. That is like the most important thing that we remember about parallel lines is that they have the same slope. So for example, if I wrote the equation y equals 2/3 x plus 5, noticing that the slope for this one is 2/3, if I wrote another equation that was y equals 2/3 x minus 10, those two lines would be parallel. And I know that because the slope is the same. So I know that they would never intersect because they have the same exact slope. And we'll look at what that looks like on a graph in a little bit. But here they also kind of give you just like a little visual representation. This is how you use the parallel symbol. So we would say the line M is parallel to the line N. Then perpendicular lines are like the total opposite. They are going to intersect, and they intersect at a right angle. The symbol to show perpendicular is that little upside down T. So for perpendicular lines, we want to talk about the slope of those as well. The slope is going to be something called opposite reciprocal. So we've used that word reciprocal before, like when we've been solving equations or inequalities. We know that means to flip a fraction. Reciprocal tells us to flip something. The opposite part means we change the sign. So opposite means we change the sign. Reciprocal means we're going to flip the value. So for example, if I had y equals 4/5 x minus 2, and I wanted to make a perpendicular function, I would take that slope 4/5 and I would change the sign so it goes from positive to negative, and then I flip the fraction over. So the perpendicular slope would be negative 5 over 4 x, and then I'm just going to make up another y-intercept. So the main thing to focus on here is what we did to that slope. We went from positive 4/5 to negative 5 over 4. Let's do just like another example over here. If I had the slope m equals 4, the perpendicular slope, so I'm going to use that upside down T, the perpendicular slope of positive 4 would be negative because I changed the sign and then I flip it. Well, 4 is really like 4 over 1. So when that gets flipped, my perpendicular slope would be negative 1/4. And one more just to make sure we're good to go here. If I had a slope of negative 2/3, the perpendicular slope there, I change the sign and flip. So that would make it positive, and then I flip the fraction, so it would be 3 over 2. So there's just a couple more examples of what perpendicular slopes look like. Now I'm going to skip reading this first part up here because it has to do with something we skipped. But number 8 says write equations for 3 lines that are parallel to the line y equals negative 2x plus 4. So you could make up your own examples. I'm just going to put 3 here so that you kind of see an idea of what parallel lines look like even more. So I know that for parallel, I need to have the same slope, and the slope here is negative 2. So if I want to write 3 more parallel lines, I need to make sure they have a slope of negative 2. And then I'm just going to pick my favorite numbers, honestly, to be the y-intercepts. It could really be anything. So here are just like 3 more examples of parallel lines. I'm going to leave that one as just negative 2x, so it would have a y-intercept of 0. So in this little notebook section, now to connect that with the point slope lesson that you just watched, we are going to be given an example that looks like this little notebook right here. And they work through all the steps on this one. So if you ever need to reference back to another example, this is a good place to go. But the directions for the question say to determine an equation of a line that is parallel to y equals 3/2 x minus 4 and that passes through the point 4, 7. So you'll notice here I've been given a point, and since I'm making a function that's parallel to y equals 3/2 x minus 4, I can get the slope from this line. So we should be thinking, oh, of course, we're going to use point slope form. I have a point that it goes through, and I know it's parallel, so it's going to have a slope of 3/2. So they kind of talk about that here. 4, 7 becomes our x1, y1, just like they say there. And we substitute that into point slope form. And for today, we're just going to plug it into point slope form. We will practice more solving for y later on. So here on number 9, we'll do our own example. Write an equation for the line that is parallel. So anytime I see that in the question, I underline it because I know it's important. Parallel to the line y equals 5x plus 3 and passes through the point 4, 0. So the 2 things that I know I'm going to need, I need the slope, which since it's parallel, it's the same slope that I'm using. And I use the point 4, 0. That's my x1, y1. Now we're going to plug that into point slope form. So when I start writing my point slope form, I start with y minus, the y1 is 0. Then the slope is 5 parentheses x minus 4, and then I close it. So that's how I would plug in point slope form for a parallel line that goes through the point 4, 0. Now we may come back later and solve for y on this one, but we're going to leave it like this for now in point slope form and move straight on to the next section. Now we have the perpendicular example. So we are first asked to write 3 equations of lines that are perpendicular to the line y equals negative 2x plus 4. So my slope of this line is negative 2. And I know with perpendicular lines, that's when I have to do the fancy stuff. Something that helps me remember is perpendicular is a really long word and it sounds complicated. So that's the one we have to do the complicated stuff too. So to find my perpendicular slope to negative 2, remember I change the sign and flip. So I change the sign from negative to positive, and then I flip 2 over to give me 1/2. So positive 1/2 is our perpendicular slope. And then we'll use that to just kind of like make up the rest. So 1/2 x minus 5. Y could equal 1/2 x plus 12. Or it could equal 1/2 x minus 32. But you get the gist of we change the sign and flip, and then the y-intercepts will look different. To determine an equation of a line that is perpendicular to y equals -1/2 x plus 4, and that passes through the point -3, 5, they walk you through those steps in this little notebook section again. It's really similar to the last one we just did. The only difference is we have to make sure we use that perpendicular slope. So perpendicular means we change the sign and flip. So here in their example, the slope was -1/2. And here in step 1, they talk about changing the slope to +2. If it's perpendicular, it's going to be +2. Let's try number 11. So again, if you need to reference like another worked example with the steps written out, you can look at that little notebook section that I've now circled 12 times. Okay, write an equation for the line that is perpendicular, underline it, you know it's important, to the line y equals 5x plus 3 and passes through the point 4, 0. So I know right away if I see perpendicular, I need to be changing my slope. So I like to write that to the side on its own. I'm changing it from 5 to the opposite reciprocal. So it's positive, I need to change it to negative. And then the number 5 flipped into a fraction would be 1/5. So my slope becomes -1/5. It should look like the complete opposite of the number 5. And then it goes through the point 4, 0. We don't have to do anything fancy or different with that. We just label it x1, y1, and we're good to go. So we're going to plug into point slope form again. I'll write it there to remind you. As we go and fill in everything in point slope form, we start with y minus, and then the y1 is 0. It's equal to -1/5. And then in parentheses, we would have x minus 4. And again, we're just going to stop here for this part of the lesson. We will continue to solve for y later on. One thing I do want to make sure I do a better job of mentioning, perpendicular lines have these crazy slopes, like these opposite reciprocal slopes, because they meet at 90-degree angles. I know I read that in the definition, but I wanted to remind us what those would actually look like. So when the slopes, even though they might like look a little different when we graph them, so if that's my x and y axis, I'll just give you a little example. My slope for the first line could be something like this. When I change the slope to the perpendicular one and it goes on the graph, they should look something like this. So it's like they cross at an x, but they meet specifically at 90-degree angles. And then remember, parallel lines, they will never meet. They have the same slope, so they'll never touch. So here we have a couple examples that we're going to work through before we're done for today. They give us a line and a point on this graph. And first, we're going to write the equation for f of x. So when we write equations from graphs, I like to start by identifying my y-intercept, because I know I'm going to write this in y equals mx plus b form. So my y-intercept is -2, and I can just count my slope on the graph. So I want to make sure I pick 2 pretty points, 2 points that go through the corner of the little squares. And then I count rise over run. So for this one, I would count down 1, that's a -1. And then I would have to go to the right 1, 2, 3. So my slope would be, it has a rise of -1 and then a run of 3. All right, So now I just plug that into this y equals, and our line is negative 1/3 x minus 2. Now they want us to write an equation of a line that is parallel to f of x, that passes through the point -6, -5, and they show that right here also, that little point. So that's our x1, y1, and we're going to write that in point slope form. So we start with y minus, the y1 is -5. As soon as I write minus a negative, I want to make sure I change it to plus plus, so I don't forget. Then I have my slope. Since it's parallel, the slope is the same for this equation also. So it's -1/3. And then in parentheses, we would have x minus, because that's part of point slope form, -6. Close the parentheses and go ahead and add those plus signs back in. So to just make that look a little prettier, we have y plus 5 equals -1/3 parentheses x plus 6. So that's what that equation would look like in point slope form. The next example that we will do is going to have us write an equation in perpendicular. That is perpendicular to the line that we write first. So now we're given a table of values for g of x. And from this table, in order to write an equation, we need to find the slope. So I'm going to pick -4, 5 as my x1, y1, and 0, 6 as the x2, y2. So in order to find the slope for this one, I need to do slope formula. y2 minus y1 over x2 minus x1. So it's kind of like we got to start putting all the stuff we've learned about linear functions together. When I plug in my values, I should have 6 minus 5 over 0 minus -4. Change that to plus plus. 6 minus 5 in the numerator is 1, and 0 plus 4 is 4. So the slope for this line up here is 1/4. Now we're not done yet. I know that's going to be y equals 1/4 x, but I need to think about my y-intercept, because that would finish my equation. Well, when we have an x value of 0, that is where we will find a y-intercept on our graph. So the y-intercept for this one is at 6. So there's our equation for this line from the table for g of x. Now part B wants us to write an equation of a line that's perpendicular to g of x and that passes through the point 3, -4. So I know 3, -4 is going to be my x1, y1. But I have a perpendicular line this time. So before I can start plugging into point slope form, let's go ahead and write down our perpendicular slope. So the slope up here was positive 1/4. I need to change the sign and flip. That's what you should say in your brain every time you've got perpendicular slope. You got to change the sign and flip. So I change the sign, then it becomes negative. And then I flip it. 1/4 flipped upside down would just be 4. So my perpendicular slope for this one is -4. Let's plug in point slope form. Y minus y1 is -4. Let's go ahead, plus there. Y equals, just equals, -4 parentheses x minus 3. So just to kind of clean that up a little bit, let's go ahead and just write that as y plus 4 equals negative 4 times x minus 3. So that's what the perpendicular equation would look like. And then eventually we will solve for y and actually like be able to graph all of these and all that good stuff. Whoops.